There's a man, let's call him Mick, who can tell you what's wrong with a diesel engine just by listening to it for a few seconds. He can smell overheating oil, feel worn injectors through the vibrations in the frame, and fix most faults with a socket set and a stubborn refusal to be beaten. For decades, people like Mick have kept the construction and demolition wheels turning. But soon, their kind could disappear. Across the globe, the march toward electric and hydrogen powered construction equipment is accelerating. We hail this as progress, and in many ways it is. Cleaner air, reduced emissions, quieter job sites, and smarter diagnostics. But beneath that gleaming vision lies a silent casualty, a generation of diesel engineers whose knowledge, experience, and instinct cannot be replicated by software or replaced by code. And as the world moves forward, we may be leaving behind those who built it. Diesel engineers are more than just mechanics. In many ways, they're interpreters, reading the unique language of combustion, pressure, timing, and friction. They know the sounds of strain, the smells of burning, the feel of imbalance. They don't plug in laptops, they tune by ear, by hand, and by experience. They've spent years, sometimes decades, learning the quirks of different engines, understanding how machines age, how they fail, and how to bring them back to life. And they've done it in the cold, the rain, the dark, often with limited parts and less than ideal conditions. They are craftsmen, field doctors, diesel whisperers. They're warriors with grease under their fingernails and stories etched into every scar on their hands. But pretty soon, their tools will no longer be enough. Electric machines don't have injectors, timing chains, turbos, or head gaskets. They don't leak oil or overheat coolant in the same way. Instead, they come with inverters, high voltage circuits, battery management systems, and sealed components. They break differently, and crucially, they're often designed not to be repaired by independent engineers at all. The transition to electric and hydrogen propulsion systems shifts the center of gravity in maintenance from mechanical intuition to software access. The job becomes less about problem solving and more about code reading. And if you don't have the diagnostic tool or the OEM's permission, you're locked out. This is not an evolution of skill, it's a revolution in system access. And revolutions have a nasty habit of leaving people behind. We now found ourselves in a strange liminal period. Diesel is no longer the future, electric is not yet the norm, and hydrogen remains years away from widespread adoption. In this in between hinterland world, many companies still run diesel fleets. But as those machines age and new ones come with electric or hydrogen systems, the gap between what exists and what's coming grows ever wider. Young engineers entering the trade will soon not know which skill set to chase. Should they master diesel, which still dominates many fleets? Or should they learn electric systems and risk being underexperienced for the jobs that still make up most of today's workload? Meanwhile, veteran engineers, those who can rebuild an engine blindfold, are being subtly pushed aside. Their knowledge is seen as legacy, their salaries seen as cost centres, their training seen as a sunk investment. And so we teeter on the edge of a skills vacuum. Let's be clear, diesel engineers are not stubborn Luddites unwilling to change. Most would happily upskill if they were given the chance, and the tools, and the respect. But in too many cases, companies see no value in retraining. Why invest in someone nearing retirement? Why waste money bridging the gap when younger, cheaper engineers can learn digital from day one? And this short term thinking ignores two hard truths. Electric machines still share common ground with their diesel ancestors. Hydraulics, undercarriages, final drives, track systems, cooling systems, structural stress, they all still fail. Wisdom takes years to learn and to earn. You can teach a new recruit how to replace a sensor, but you can't teach them to know when that sensor is lying or how to improvise when the replacement part is 2 days away and the job has to be done today. Without those veterans, we risk losing the unwritten manual of real world maintenance, a body of knowledge that lives in the fingertips of seasoned fitters, but not in corporate training modules. OEMs are increasingly restricting who can maintain or repair their equipment. Proprietary diagnostics, lockdown software, and even physical tamper proofing mean that independent fitters and in house mechanics are being frozen out. And that's not just bad for old school engineers, it's bad for contractors, bad for productivity, and bad for long term cost control. Imagine a world where every issue, from a blown fuse to a sluggish actuator, requires a factory certified technician to attend. Imagine fleets sidelined because no one local has the tools or the authority to make a simple repair. Now stop imagining, because it's happening already. And while this reality slowly descends upon the West, its effect in the global South, where second-hand diesel machines are still king, could be even more disruptive. But suffice it to say, if Western fitters are being left behind, technicians in developing countries may not even be invited to the new era. So we face a choice. We can treat diesel engineers as relics of a dying era, watching them quietly retire or be pushed out with a pat on the back and a cheap clock. Or we can honour their experience, document their knowledge, and empower them to guide the next generation. Imagine a training centre where veteran diesel engineers pair with young apprentices explaining the why behind every bolt and misaligned bearing, even as those same apprentices teach them how to read schematics for EV control systems. That's a bridge. Anything less is a burn pile. The diesel engine powered more than machines. It powered careers, families, communities, identities. And those who kept them running did more than just fix equipment. They kept sites operational, projects moving, and downtime minimal. They are not disposable. Their knowledge is not outdated. It's the foundation on which this new era is being built. So as we chase our electric dreams and hydrogen hopes, let's not forget those who still carry the spanners, who still know what a rattle in the manifold means, and who still believe that fixing something with your hands is as noble as building it with code. Because one day, when the lights go out or the software fails, we may need someone who remembers how machines used to speak before they went silent.